Okay, today we're going to look at simplifying radicals using a method called factor trees. There are more than one way to simplify radicals. This is just one particular method, so we're going to give it a try. First, I remind myself of what a factor tree is. Factor tree is when you're breaking down any kind of number. Tree is just the way we look at it, but a factor tree is when we break down a number into its prime factorization. It's really what we're looking at doing. So I wonder what goes into 12, so I can break that down. I can say 2 times 6 is 12. 2 is a prime number, so I'm good there. 6 is composite. I'm going to have to keep going. What goes into 6? Well, let's see. 2 times 3 would give me 6. And since 2 and 2 and 3 are all prime numbers, I do have my final answer, 2 times 2 times 3. So 2 times 2 times 3 does give me 12. So that is the prime factorization of 12. Now, how does that relate if I'm looking at a square root? Well, let's check this out. What if I were wanting to do the square root of 12? Okay, similar problem. So what I'm going to do is I'm going to approach the problem just like a factor tree. I'm going to break it down. And again, all the same numbers. 2 times 6 is 12. And 2 times 3 is 6. But in this case, what I really have is 2 times 2 times 3. Notice I left that inside a radical sign this time, right? So similar kind of work. And what I want to do is recognize that anytime I have two numbers that are a pair of numbers, and that's actually right here, that's actually a perfect square. And as we talked about previously, anytime you have a perfect square inside a square root, you can do that. So what I'm going to do effectively is I'm just going to take that out, and then whatever is not perfect remains on the inside. So since the 2 was perfect, it comes out. The 3 is non-perfect, it stays on the inside. And you can see 2 square root 3 is a simplified version of the square root of 12. Let's try the same idea with two other examples, please. We'll start with the square root of 18. So I'm going to look at the prime factorization. Let's see what goes into 18. There's a lot of things, but since it's even, I'll start with the 2. 2 times 9 is 18. 2 is prime, so I'll keep breaking down the 9. Let's see, 3 times 3 gives me 9. So I currently have 2 times 3 times 3. And double check that. 2 times 3 times 3 does give you 18. And these are all prime numbers. Now, where is the perfect match? In this case, the 3's are perfect. So I'm going to take them out because they're perfect, and I'm going to leave all of the non-perfect numbers on the inside. So 3 square root 2 is the simplified version of the square root of 18. Go ahead and try the square root of 48 on your own. Alright, let's see what we can come up with here. So, again, the square root of 48, I'm going to try my prime factorization. Again, there are multiple numbers that go into 48, 2, 3, 4, lots of numbers, but since it's even, I'm going to start with the lowest prime. That's 2 times 24. 2 times 24 is 48. 2 is prime, so I'll move on to the 24. Let's see, 2 still goes into there, so let's see, how about 2 times 12 for 24? I can keep going. Let's see, I've got 2 times 6 here for the 12, and looks like 2 times 3 for the 6. So you can see the prime factorization, 2, 2, 2, 2, and 3. So I'll write that down. 2 times 2 times 2 times 2 times 3. All right, this presents a situation here. Remember, any pair of numbers is perfect. But in this case, I actually have two pairs. Look at that, 2 pairs of perfect numbers. So I'm going to take both of them out. That 2 is perfect, and this 2 is perfect. And I'm going to be left with my non-perfect number on the inside. So the question, what do you do with the 2 and the 2? Well, it is multiplication, so 2 times 2 becomes 4, and the answer is 4 radical.